Hey, Algebra Show, Stirp here. So we're going to start on with this trig unit. Hopefully you're having a nice evening. And remember, you get 20 minutes on Tuesday or Wednesday to finish up that test. And if you need more time, just let me know. So we're going to review the sine, cosine, and tangent. I don't do this as SOH CAH TOA. I do as some old hippie caught another hippie tripping on acid. But just my little funny. So we're going to be talking about 3069 triangle, things such as that. So remember what it means. What is it? How does it help us? So if I find one of my angles, then if I had, we'll call this theta, so that would mean that sine would be the opposite over the hypotenuse, A over C, because opposite over hypotenuse. Cosine would be the of theta on both of those. Cosine would be the adjacent, so the side that completes the angle and the hypotenuse. And then tangent of theta is the opposite, A over B. Okay, opposite over adjacent. So hopefully you remember that. We're going to start talking about the reciprocal. So 1 over sine is equal to the cosecant, so we use CSC. So it's the reciprocal, so you flipped over a fraction. So 1 over sine is cosecant. Secant is the opposite of cosine, and cotangent is the flip over of tangent. So find the 6 ratios of each for both angles A and B. Okay, so we're going to go sine of A is going to be, oh, and that's a 5, 12, 13. I don't know if you remember that, so it's going to be 5 over 13. The cosine of A is going to be the adjacent over the hypotenuse. The tangent of A is going to be 5 over 12. And then I could go up to angle B, but I'm going to do the reciprocal. So the opposite of sine is cosecant. I know that we should have it be the same, but it's just going to be 13 over 5, so I flip it over. The secant, that's the reciprocal of cosine, is going to be the flip over, so 13 over 12. And then the cotangent of A is going to be 12 over 5. Okay, yes, it did ask to find the whole thing with B, so basically you do the exact same thing. Realize the opposite and the adjacents flip-flop, the hypotenuse is the same. This particular problem, this is going to be 4, that's a 3, 4, 5 right triangle. I guess I should specify those are right triangles. So let's use B in this case. So I'm going to say the sine of B is equal to 3 over 5, opposite over hypotenuse. Cosine of B is going to be the adjacent over hypotenuse. Tangent of B is going to be opposite over adjacent. And then I'm going to do the reciprocal identity. So the cosecant is the reciprocal of sine, which is 5 over 3. The secant of B is going to be 5 over 4. And the cotangent of B is going to be 4 over 3. And again, yes, they asked us to do A, but that's just where we would flip-flop a few things, but that go from there. Let me know if you have any questions about that. So Pythagorean triples are when we come out to this. There's actually an infinite amount. This is this should be 15, I believe. And it's not it kind of erased. Yeah, there it's erasing. So these are Pythagorean triples, meaning that we get whole numbers when we deal with it. I'd say the 3, 4, 5, and the 5, 12, 13 are the ones you see the most often, and we'll just go from there. Okay, but there's also, there's a website you can check on all these Pythagorean triples. There's an infinite amount, and there's no reason to really know really much more than just these two. And if you ever forget one when you do the Pythagorean theorem and it comes out to a whole number, once you take the square root, you realize you're dealing with a triple. So simplification review for rationalize the denominator. So we don't want to have a radical in the denominator for the most part. So this becomes a square root b, and then this becomes b squared, and square root of b squared is just b. So if we do the same thing here, I'm going to get root 2 over root 7. Root 7 multiply top and bottom. So I'm going to get root 14 on top over root 49, which is just 7. You cannot reduce inside to outside. So don't reduce top to bottom if you have radicals. But you can go inside a radical to inside a radical and outside. So that's going to give me 5 root 3 over root 9. Root 9 is 3. And there's our answer here. If I go root 2 times root 2, it's going to give me 4 root 2. Root 2 times root 2 is root 4 over 2. So here I can indeed reduce. So that's just going to give me 2 root 2. And it's over 1, but you don't have to put anything else. So what would be true about an isosceles triangle? An isosceles triangle, you have two sides that are equal, but you also have the base angles that are equal. So again, we have two sides that are equal, base angles are also equal. The hypotenuse of this would be 3 root 2. The hypotenuse of here would be 5 root 2. We use the Pythagorean theorem. So that means that a root 2, if you knew that you had an isosceles triangle, the hypotenuse is always the square root of 2 times bigger. And again, if you use the Pythagorean theorem to give, you'd nail it. Okay, so there's a 45, 45, 90. So it's still isosceles. So if that's 12, that's 12. That has to be 12 root 2. Again, if these are the 45s, and you know they're going to be 45s because we have these sides are equal. So in order to get our hypotenuse is going to be 12 root 2 times root 2. Root 2 times root 2 is root 4. Root 4 is 2, so 12 times 2 is 24. So A would be 24 in this case. As we move down, I know that this is also going to be 8. This would then be 8 root 2. This one, those are both of my 45s. We don't know the unknown, so I was multiplying by root 2 to go out there, but now I'm going to divide by root 2. So this becomes 15 root 2 over root 2, and I can indeed cancel those, so I just get 15. And if that's 15, this one also has to be 15. And again, same idea. This is going to be 3 root 2, which is 3 root 4. Root 4 is 2, so this would be 6. And if we had this one, D would be 5 root 2, no matter which way we did it, because it's just the hypotenuse of our isosceles triangles. And then if we needed to go backwards, remember I'm going to divide by root 2. So this is going to be 12 over root 2. You don't want the root 2 downstairs, so multiply both top and bottom by it. So you get 12 root 2 over root 4, which is 2, which means this is going to go ahead and reduce to 6 root 2 and 6 root 2. Again, we're going to divide by root 2. So this is going to get 10 over root 2. Multiply top and bottom by root 2, so you get 10 root 2 over root 4, which is 2. And then again, you can go ahead and reduce outside to outside. It's going to wind up this being 2 root 2, and this is also 2 root 2 because it's isosceles. What do we know about the equilateral triangle? Well, an equilateral triangle has all three sides being the same. So that would be A, and A. Okay, so we got to keep that in mind. We also know that each of the angles are 60. And the nice thing about this is if we drop an altitude in, so we cut that angle in half, this becomes a 30-degree angle, this becomes a 90, and same thing on this side, 30 and 90. And so equilateral triangle has basically made up of two 30, 60, 90 triangles. So if we know this, let's see. This is my short side being 30. This is my long side being this. So side opposite is always the smallest. Opposite of 30 is always the smallest. The hypotenuse is always double. Opposite of the 60 is always 12 root 3. It's root 3 times bigger than the opposite of the, 6 root 3, excuse me. 6 root 3. It's always square root 3 bigger than the side opposite of the 30, or it's root 3, divide by root 3 to get to the side. So again, this one, if this is a 30 and this is a 60, if we wanted to find that, if we use the Pythagorean theorem, what we're going to do is we have the side opposite of the 60, well, the side opposite of the 30 is 4, so this is going to give me 4 root 3. So generalize, let's see, can I move over? Generalize. So the side opposite of the 30 is x. The side opposite of the 60 is going to be x root 3. And the side opposite of the 90, which is known as the hypotenuse, will always be 2x. Double it. Now back to the 45, 45, 90. So if that's 12, that's 12. That gives me 12 root 2. Well, on this one, I'm going to go 12 root 2 times root 2, which is 12 root 4, which is going to give me just 24. So opposite of 30 is 7. That means the hypotenuse has to be double that, 14. The opposite of the 60, because that's going to be a 60-degree angle, is going to be 7 root 3. Again, we know this has to be 30. This has to be 60. And the side opposite of the 30 is going to be, excuse me, half of the hypotenuse. So that's going to give me 12. The side opposite of 60 is going to give me 12 root 3. And again, this last problem, let's see what we're going to have. Oh, we have opposite of the 60. So if I'm going to go backwards, I have to divide by root 3, rationalize it, multiply both top and bottom by root 3. So I get 15 root 3 over root 9, which is 3. Reduce that. So that's going to give me 5 root 3. So the hypotenuse has to be double that, so that's 10 root 3. Notice I only double the outside number, I don't double the radical. And again, if I want the opposite of this, I'm going to divide by root 3, opposite of 30. So that's going to give me 9 root 30, or 9 root 3 over 3, which reduces to 3 root 3. So if that's that case, the hypotenuse has to be double the side opposite of the 30, which is going to give me 6 root 3. And I think that's it. So why don't you take a look at the Trig A worksheet, and I would say do as much as you can. Give me an honest 20 minutes on it. So get as much as you can done in 20 minutes. I'd say maybe start with the odds, and if you still have some time left, try some of the evens. Sound like a deal? All right, have a great day, everybody. Thanks so much. Bye-bye.